3D printers are an additive process, which means material is added layer by layer to produce a part. This can create little waste and produce complex shapes for prototypes. I'm going to talk about material extrusion, vat polymerization, powder bed fusion polymers, and powder bed fusion metals. Material extrusion uses thermoplastic filament. So it feeds this filament through a heated nozzle onto a build plate by the layers. The good news about this one is it is low cost. Vat polymerization uses photopolymer resin, which is a thick liquid-like substance that is placed inside a vat that gets cured by a UV light. So SLA will scan the layer, while DLP cures an entire layer at once. The good news about this one is it has a really good surface finish. Powder bed fusion polymers use thermoplastic powder. So the SLS fuses these powder particles together using a laser by heating or melding. The good news about this one is it doesn't need supports. The last one is powder bed fusion metals. So it uses metal powder like stainless steel or aluminum. There are two different kinds. One of them is DMLS, which heats just below the melting temperature to fuse these particles together on a molecular level. The other one, SLM, uses the laser to actually melt these powder particles together. And the good news about this one is it has great dimensional accuracy. Each of these different types of 3D printings will require different types of post-processing. Some of the main ones for material extrusion are removing supports, sanding if you want a smoother finish, or using an acetone vapor if you printed with ABS. So this kind of melts the sides a little bit so you don't really see that layer separation. For vat polymerization, you're also going to need to remove supports if you have any, and if you want a smoother finish, sand. But for this one, it's preferable to use wet sanding over standard sanding. For powder bed fusion polymers, since you're printing in a powdered bed, you're going to have to remove whatever loose powder there is at the end. And if you dip it in a silicone coating, you can actually make this piece watertight. For powder bed fusion metals, again, printed in powder, so you'll need to remove the loose powder, but this one needs support. So you're going to have to remove the supports if there are any. And since you're printing with metal, you're going to want to do a heat treatment in order to release this internal stress. In order to create a 3D part, the first thing you want to do is make a CAD model. And this basically is a digital blueprint of whatever you're trying to print. Then you'll save it as an STL file, which uses triangles and polygons to describe the object's surface. Then you'll import it into a slicing software, and this literally slices the design into layers so it can send a specific coded instruction to the printer on what to do. So for example, how fast to move, where to move, what temperature to print at, things like that. And then you'll save it as a G-code, send it to the printer, then the printer prints it, then you remove it, and then you post-process it as needed. There are two types of 3D printers that you don't need supports for. One of them is the powder bed fusion polymer, SLS, and the other is binder jetting. And that's because these are both printed in the powdered beds, so the powder itself acts as a support. Powder bed fusion metals also print in powder beds, but because you're printing with metal, it requires a higher heating temperature, and so you're going to need supports for that. If your printer is not extruding filament, one of the causes could be because of an improper print temperature. So you could be printing too low, and you'll have to increase it in order for the filament to heat to its proper temperature, thus get softer and melt and be able to extrude. Another cause could be a nozzle clog. So filament literally just gets stuck inside of it. So you're gonna either want to purge the material or do a cold pull. And the last one, while not as likely, has actually happened to me, is having improper settings. So there could be some communication issue between the slicer and the coating and the printer, and it's not sending the proper instructions that's needed. So again, different filament requires different printing parameters. So for PLA, you want to print between 180 to 220. a bed temp of 50 to 60, and a speed of 55 to 60. For ABS, since this is a harder material, you want a nozzle temp between 220 and 240, a bed temp of 105, and a speed between 45 and 55. For TPU, this is a flexible material. So you want a nozzle temp of 200 to 240, a bed temp of 50 to 60, and a really slow speed of 10 to 30. For the last two, you're gonna wanna put it in an enclosure. But of course, whatever material you're printing with, you're gonna wanna check the actual manufacturing company that you're using and see what they say as their printing parameters. There are so many things that can go wrong with a print. Two of the main ones are warping and poor bed adhesion. If you're experiencing warping, this is because of differential cooling. Some of your print is cooling faster than other parts. So one way to fix this is printing at a higher bed temperature, and another way to fix this is printing slower. If you're experiencing poor layer adhesion, this is again because your layers are cooling faster than other layers. So you can either increase the extrusion temperature, so the actual filament is hotter, being able to meld together better, or turn off the active cooling fan, so you're not cooling your print as you're trying to print. Three solutions that 3D printers have solved that stuck out to me were hearing aids, hollow ducts, and dental crowns. The first and last because they are fitting a person's specific anatomy, which I think is really cool, and then hollow ducts just because. And that is all. Thank you.